In today's class, we'll learn about sign convention for lens. Before going to the topic, we'll just see the letters which represents different distance for lens. First, we'll see. So here I have shown a reference line and one convex lens is shown, and here the point O, it is actually the optic center of the given convex lens. Now if you are placing an object, we place the object in front of the lens, and always to go along with the convention, we place the object on the left side, okay, on the left side of the lens, and the distance between the lens or the optic center and the object, it is actually the object distance. So that object distance is represented using letter U. So it is the distance between the object and the optic center. So we can write object distance as U. Okay, then we have the focal length of convex lens or concave lens. It is represented using letter F, small letter F, and the image distance, that is image can be virtual or it can be real. So anyhow the distance between the optic center and the image, whether it is on the left side or right side, the distance between optic center and the image, we name that to be image distance, and that image distance is represented using small letter V. So these are the notations. Object distance is represented using U, focal length using F, and image distance is represented using letter V. Then we have the height of the object, size of the object or height of the object. Height of object is usually represented using H suffix I, and height of image, it is represented using height of object is represented using HO. O is object, and height of image is represented using I. I is image. So these are the main notation. Now we'll come across another term, which is magnification, which is represented using letter M. So that I'll tell you when I give the definition or equation of magnification. Now let's directly go to the sign conventions. What all rules are there for taking sign convention, and what all things we have to remember, or what are the shortcut method for remembering these sign conventions. Now let's see the rules for applying sign convention. So always consider when you are learning sign convention, it is better to consider the position of the lens, object, and image as if we are drawing a graph. That is, you know that for a graph we have y-axis as well as x-axis. So we have let this be the y-axis and this be the x-axis. Okay, so it is somewhat similar to drawing graph in mathematics. We are going to take the sign convention also. So it will be, if you compare it with a graph, then it will be easy for you to learn. Okay, so in a graph we always take the measurement, or we always do the measurement from the origin. Okay, so imagine that our lens, whether it is convex or concave, it is placed on the y-axis. Okay, so that the origin and the optic center of the lens is coinciding. So always you should take the measurement from the optic center. So that if you are measuring towards right, then your measurement should go like this. If you are measuring towards left, your measurement should go like this. Okay, so always keep the lens on y-axis such that the optic center is at the origin. Okay, so all the measurements should be done from the optic center. So that is the first rule. All the distances should be measured from the optic center. Now, according to this sign convention, we take or we consider that the direction of incident ray is from left to right. That means we always consider that the light is coming from left and is moving towards right. That means we will place always the object on the left side of the lens. It doesn't mean that we can't place it on the right side. When we are following a sign convention, we have to apply the rule for all the cases. So that's why when we are doing numericals, uh, always we'll follow this sign convention. So it doesn't mean that we can't place the object on the right side. We can of course place it on the right side, but the rules or the sign convention when we are placing it on the right side will be different. Okay, so always keep the object on the right side so that the incident ray means the ray which is coming from the object, that is in the direction from left to right. So that is the first next rule which you have to keep in mind. Now, the third point to be remembered is distances measured along the principal axis in the direction of incident light is always taken as positive. That is, suppose I am measuring in the direction of light. So in the direction of light means from left to right. So if I am measuring from left to right, all the measurement will be taken as positive. So here, since I am starting from the origin, always we should start from the origin while measuring. So all the measurement in the direction of incident light means only those measurement on this side, isn't it? So that will be taken as positive, because when we are taking measurement on this portion, you will be measuring on the opposite direction, isn't it? Because we have to start measuring from the origin. So only those measurements which lie on the right side of the optic center will be taken as positive. So if you look at the direction, you can see that the direction here is same as the direction of incident light. That is what is meant by the third point. The distance measured along the principal axis in the direction of incident light is taken as positive. Okay, now the next point is the distance measured along the principal axis in the direction opposite to that of incident light is taken as negative. That is, incident light, as I told, is from left to right. So those measurements which we measure in the opposite direction. So opposite direction means all the measurements that we do along this portion. Okay, that will be taken as negative. So this portion will be taken as negative. So we can write here negative. So this side is negative, this side is positive. Okay, now moving to the next rule. The distance above the principal axis is taken as positive and those below the principal axis is taken as negative. Okay, so you can see that the distance which is measured, so principal axis, you know, it is now the x-axis. So all the distances above x-axis. So this portion above x-axis means this portion will be taken as positive, and all the measurements which we take in the downward direction, that is taken as negative. So this is similar to that of a graph paper. You know that those portions which we measure on the right side of the graph is taken as positive, isn't it? On the left side of the origin we take it as negative, and on the top portion, that is all the positive y-axis, we take that to be positive, and the measurements which are done in the downward direction, that is along the negative y-axis, we take it as negative. So same technique is used in lens also. Those measurements which are on the left side, we take it as negative. Right side, we take it as positive. Top, we take it as positive, and bottom, we take it as negative. So if you know how to draw a graph, the same technique is used as sign convention for a lens also. Okay, so now let's see what will be the case when the image is formed when an object is kept at a particular position and all. So we'll write once more, all the distances on left side, we take here it is negative. So all those on negative side will be taken as negative. Here on the right side, we take it as positive. Okay, so left side is negative, right side is positive. Then on top, we take it as positive. Then at the bottom, we take it as negative. So this is the convention for the measurement, distance measurement. Okay, now let's see the case of an object which is placed on the left of the lens here. So let's consider this diagram. So here you have an object which is named as AB, and lens, convex lens with optic center O, and it is placed on the y-axis, and x-axis is actually the principal axis. So that is the diagram. Now the ray is actually coming from left to right. The ray is coming from the object, so it is coming in the direction from left to right. So we can draw like, okay, so this is the incident ray. And as I told, all the measurement which we take in the direction towards the left side, this side it is taken as negative, and on the right side we take it as positive. Top portion we take it as positive, and down we take it as negative. Okay, so here when you are considering the distance between the object AB and the optic center O, so the distance is this much, isn't it? So that distance is on the negative side. So distance is u actually. U is the object distance. So here object distance is negative. Always the object distance will be negative because, as I told, we always place the object on the left side of the lens according to this convention. Now when you are drawing the image, let's see how the image distance is coming when when we are getting the image. Let's see what will be the convention for the image. So here I have shown the image of our object AB. So here it is actually formed due to the meeting of two refracted rays, and I got an image A dash B dash. You can see the position of the image, and we can see that it is an inverted real image. So when you measure the distance, so we are measuring from optic center, so we are going to do the measurement from optic center towards left till here, and we name that to be image distance, which is represented using letter V. So since it is on the left side, we take the image distance here as positive. Okay, so here on right side, object distance is taken as negative, and on left side the image distance is taken as positive. Now moving to the height of the image and height of the object, you can see that the object height is on top of y-axis. Okay, so object height hi will be taken as positive. Whereas here in the case of image, you can see that it is an inverted image, and so we will do the measurement in the downward direction. So we take the height of the image as negative. Okay, or you can keep in mind erect or straight object or image, whether it is object or image, we take it as positive. If it is an inverted one, we take it as negative. Okay, so that is to be kept in mind. Left is negative, right is positive, top is positive, and bottom is negative. Okay, so if you have that in your mind, then it will be easy for you to follow the other conventions. Okay, now again one more thing, this is the case of convex lens. So for case of convex lens, actually object, so I told object distance, that is u, it is always negative. We always take it as negative. Then image distance v, that will be negative, sorry, positive if the image is on left side. I'm sorry, it is on right side. So right side means the image will be real. Okay, so if image is on right side, it will be a real image, and we give v to be positive. Now if the image is on left side, okay, the image can also be on left side, the image will be virtual. Okay, so we can take the sign convention of v as negative. Okay, always virtual image. Suppose the image which we get here is virtual, you know that image will be on left side, which is behind the object for convex lens. Okay, so here for convex lens, if image is on left side, you should take v as negative, and right side we should take image distance as positive. Now always for convex lens, focal length is taken as positive. Okay, focal length is taken as positive. Now next is for height. Height of object, always it is taken as positive, because we know height of the object is in the upward direction. Then height of the image, it will be negative if it is an inverted image. Inverted means it is a real image. Inverted and real image. And height of the image will be positive if it is a virtual image. So virtual image, you know, it will be always erect. Okay, so if you have these things in your mind, then it will be easy to solve the numerical. So this is the case of convex lens. Now when you move to the concave lens, the same situation come. Only difference is for concave lens, focal length will be negative. Okay, all the same rules are applied. The only difference is concave lens will give, the focal length of concave lens is taken as negative. And you know that for a concave case, we have only virtual image. Okay, so all the conventions for the virtual image will be taken for what? As sign convention. Getting? So we'll conclude what we have learned now. So to conclude the sign conventions, you can see that for convex lens, focal length is positive. For concave lens, focal length is negative. for convex lens, U is always negative and concave also U is negative. Then for convex lens, V can be virtual or real. That is, image can be virtual or real. So V can be positive or negative. If real image on right, then V is taken as positive. If virtual image on left, V is taken as negative. Concave lens, we have a virtual image, it will be on the left, so V is taken as negative. Now moving to height, height of object is always taken as positive. Height of image, if it is a virtual image, it will be erect image, so height should be taken as positive. If it is a real image, it will be an inverted image, so height should be taken as negative. For concave lens, height is positive because we get virtual image. So this is how the sign convention goes. Now we'll move to the lens equation, lens formula and formula for magnification. So the lens formula is 1 by f is equal to 1 by v minus 1 by u. Okay, so this is the equation without applying sign convention. So for when you are doing the numericals, you have to apply sign convention. That is, we have to apply positive for convex lens. F should be positive for convex lens and F should be negative for concave lens. Then U is always taken as negative. Then V, according to the position of the image, whether it is on left or right, it should be taken as positive or negative. So the equation 1 by f is equal to 1 by v minus 1 by u. This is without applying sign convention, but when we are doing numericals, you have to apply the sign convention, put the sign properly, and then only you will get the answers correctly. Now the next formula is the formula for magnification. So the formula for magnification is m is equal to v by u, or v upon u, where v is the image distance and u is the object distance. The same can be written in terms of height. So it is height of the image divided by height of the object. So this is the formula for magnification, height of the image by height of the object, or it is V by U. Here also you have to put the sign convention depending upon the value position of the image. U is always anyway taken as negative and HO is always taken as positive, but height of the image and V. So those values will depend upon whether the image is erect, whether the image is virtual and all. Okay, so accordingly we have to apply the sign convention. So you'll understand more about applying the sign convention while we do the numericals. Next we'll do the numericals related to lens formula and magnification.